Hello everyone, my name is Anushka and I'm from BSc third year and my roll number is 205015, and today the topic of my presentation is graph theory from discrete mathematics. So first let's know what is graph. A graph G is a mathematical structure consisting of two sets V and E, where V is a non-empty set of vertices and E is a non-empty set of edges. And the representation of this is a graph. Like for in first example, V1 and V2 are vertices and E1 is edge. Here V1, V2, V3, V4, V5 are vertices and E1, E2, E3, E4, E5, E6 are edges. Similarly in this also. Now next, some basic terminology. First, trivial graph. A graph consisting of only one vertex and no edge is called a trivial graph. We can see that here we have only one vertex, so it will be a point, and this is an example. Now next is null graph, a graph consisting of n vertices and no edge. Here there are 4 vertices but there are no edge present, so this is a null graph. Third one is directed graph. A graph consists the direction of edges, then this is called directed graph. So a graph where the direction of edges is given, like this edge is going from here to here, so this is the direction of it, so this is a directed graph. Next is undirected graph, a graph which is not directed or in which the direction of edges is not given is called undirected graph. Fifth one is self loop graph. If edge having the same vertex as both its end vertices is called self loop. Like here V1, V2, V3 are the vertices and E1, E2, E3, E4 are the edges. But the edge E1 starts from vertex V3 and ends on vertex V3. So this is called self loop in a graph. Sixth one is proper edge. An edge which is not a self loop is called proper edge. Like in this example only, E1, E2 and E4 are proper edge. Next one is multi-edge. A collection of two or more edges having identically end point is called multi-edge. Like here, V1 is a vertex and V2 is a vertex and E1 is a edge connecting V1 and V2. Similarly, E2 is also an edge connecting V1 and V2. So there are more than one edges connecting E1 and V1 and V2, so it is called multi-edge. Next is simple graph. A graph which does not contain any self loop and multi-edge is called simple graph. Like here we don't have any multi-edge nor we have any self loop. Next one is multi-graph. A graph which does not contain any self loop but it contains multi-edge is called multi-graph. Like here E4 and E5 are the multi-edge of this graph. So but here there are no self loops, that is there is no edge which starts from one vertex and ends on the same vertex, so it does not contain this, but it contains multi-edge, so it is a multi-graph. Next is pseudograph. A graph which contains both self loop and multi-edge is called pseudograph. Here E4 and E5 are the multi-edge in this graph and E2 is the self loop, that is it starts from the vertex V2 and ends on the vertex V2, so it is self loop. And here there are more than one edges connecting V4 and V3, so it So these are multi-edges. So this graph contains both self-loop and multi-edge. So this is an example of pseudograph. Next is incidence and adjacency. Let EK be an edge joining two vertices Vi and Vj, then EK is said to be incident of Vi and Vj. Two vertices are said to be adjacent if there exists an edge joining this vertex. Like for example, let's take V1 and V2 as the two vertices and E2 is the edge connecting them. So E2 is said to be incidence of V1 and V2, and these two vertices V1 and V2 are adjacent to this vertex, adjacent to this edge. Like here, E1 is incident of V1 and V2, and V1 and V2 are adjacent, but V1 and V3 are not adjacent. Next is degree of vertex. So the degree of vertex V in a graph G is written as dV, and it is equal to number of edges which are incident on V with self loop counted twice. So here if we take V1, there are two edges connected to it, so its degree will be 2. Similarly, the degree of V3 will also be equal to 2, since there are two edges, this and this. The degree of V4 will be equal to 3, as we have three edges, this one and this one and this one. But the degree of V2 will be equal to 4, as we have this edge 1, this edge second, and this is a self loop, so we'll count it twice. So it will be 2, and 2 plus 1 is equal to 4. So degree of V2 is 4. Now similarly, degree of V8 is equal to 0 because there is no edge connected to it. So we say its degree is 0. Isolated vertex and pendant vertex. A vertex having 0 is called isolated vertex, and a vertex having degree 1 is called pendant vertex. Like in the last example, V8 was isolated vertex, and V7 is pendant vertex as it is connected to only one edge. Next is finite and infinite graph. A graph with finite number of vertices as well as edge is called finite graph, otherwise it is an infinite graph. Here this is a finite graph and this is an infinite graph, and it continues till infinity. Now some important graphs. First one is complete graph. A simple connected graph is said to be complete if each vertex is connected to every other vertex. That is, we have these two vertices, so this is connected to this. Similarly, here we have three vertices and it is all connected to every other vertex, so it is complete graph. Similarly, this is also an example of complete graph. Next is regular graph. A graph G is said to be regular if every vertex has the same degree. If degree of each vertex of graph G is k, then it is called k-regular graph. Like here, if we take this vertex, then its degree is 2 because there are two edges connected to it, so it is 2. Here also it will be 2. Similarly, at the down also it will be 2. So the degree of each vertex here is 2, so it is a 2 regular graph. And similarly, in this example also, we will see that it is a 4 regular graph because the degree of each vertex here is 4. For this vertex it is 1, this is 1, this is 2, and this is 3, and this is 4. So it is a 4 regular graph. Next is bigraph or bipartite. If the vertex set V of a graph G can be partitioned into two non-empty disjoint subsets X and Y in such a way that edge of G has one end in X and other end in Y, then G is called bipartite. First we'll write the set of all the vertex, that is v is equal to v1, v2, v3, v4, v5, v6, v7. Now if we take this edge and if we take this vertex, then if this vertex belongs to the set x, and then for this edge this vertex will belong to the set y. So similarly for this vertex, this belongs to x, so this will belong to y. And then for this vertex, this belongs to y, so this will belong to x. And for this vertex, we know this belongs to x and this belongs to y. So the x will contain v1, v6, v3 and v4, and y contains v7, v2 and v5. Connected graph. An undirected graph is said to be connected if there is a path between every two vertices. Like if we take A, then there is a path from A to B, there is a path from A to D, there is a path from A to C. Similarly for B also we have B to A, B to C, B to D, and similarly for all we have path between every two vertex. Now we have to note that if a graph is connected, then it will not be bipartite. Suppose we take this edge, then A belongs to the subset X, so B will belong to Y. Similarly for this edge A belongs to X, so D will belong to Y, and for this edge A belongs to X, so C will belong to Y. So C, B and D belongs to Y and A belongs to X. Now if we take another vertex B, so for this, if B belongs to X, then A, C and D will belong to Y, but we know that B, C, D were in the same group and A was alone, so it is repeated, so this will not be a bipartite. Next is complete bipartite graph. If every vertex in X is disjoint and every vertex in Y, then it is called a complete bipartite graph. If X and Y contain mn vertices, then this graph is denoted by kmn. Now if v1 belongs to X, then this means that v2 and v3 will belong to Y, and so v4 will belong to X. Now we see that v1 is connected to v2 and v3, and v4 is also connected to v2 and v3. This means that every vertex of X is connected to every vertex of Y. So this means that it is a complete bipartite graph, and it is denoted by k2, 2, where 2 is the number of vertices in X and the other 2 is the number of vertices in Y. Next is subgraph. Let GVE be a graph, then let V dash be a subset of V and E dash be a subset of E whose endpoint belong to V dash. Then GV dash E dash is a graph and is called a subgraph of GVE. Now if in this example we see that this is the graph, now if we remove some of its edges like this one, then the graph becomes this. So this is the subgraph of this graph. It is similar to subset of a set. Next is decomposition of graph. A graph is said to be decomposed into two subgraphs G1 and G2 if G1 union G2 is equal to G and G1 intersection G2 is a null graph. That is, if we break the graph in two parts and if we take its union, it should be the same graph. And if we take the intersection of this graph, then it should be a null graph. Next is complement of a graph. The complement of a graph G is defined as a simple graph with the same vertex set as G, where two vertices U and V are adjacent only when they are not adjacent in G. That is, if we take this graph, now if we draw an edge from Z to U, U to V, V to W, that is, connect all those edges in this graph which are not connected, and all those which are connected, if we remove it, then we get the complement of this graph. Then we get this diagram after doing so. So this is the complement of this graph. Another example is if we take this rectangle, these are the vertices. So now if we remove these vertices and connect those vertices which are not connected, that is this and this, so the graph which we get will be this and this. So this is the complement of this graph. Next is planar graph. A graph which can be drawn in the plane so that its edge do not cross is called planar graph. Like in this example, these two edges are crossing it, so we remove one of its edge and we redraw it in other way so that it is connected to it, but they do not cross each other. So this is called a planar graph. Thank you. That's the end of my presentation.